In this lesson, we're going to be adding and subtracting polynomials. So let's start by identifying the parts of a polynomial. Let's talk about what polynomial means. The word poly means many. So we have a polynomial here with many terms. We have negative 5x to the third plus 4x to the sixth plus 10x squared minus 8. Let's go ahead and talk about the following as it pertains to this polynomial. We have something that's called a descending order. Well, a descending order means that I would start at our highest exponents and then go to our lowest exponents in that order, ending them with our constant. So I would have our 4 is our highest, 4x to the sixth. Then I have the next highest exponent is 5x to the third plus 10x squared minus 8. All right, so now let's go ahead and talk about what the coefficient of x squared would be. Well, remember the coefficient is the number that is with a variable. And so since we're talking about x squared, we're going to be talking about the 10. 10 is the coefficient of x squared. The coefficient of x to the third power is this whole, and because there's a minus there, it's negative, is our coefficient. The leading coefficient is the first where we have the first in our order here. It's the coefficient that goes with our highest exponent, and so in the descending order, and so that is going to be 4. The number of terms in this polynomial, well, the number of terms that we have here is we have negative 5x to the third is a term, plus 4x to the sixth, plus 10x squared, and minus 8. All of these are the terms, and the terms are separated by those operations. So the number of terms that we have in this polynomial are 4. So now let's go ahead and talk about what a monomial, a binomial, or a trinomial is. Well, these refer to the number of terms that we have in each of them. So if we have a monomial, well, we know that mono means 1. So it's going to have one term. So it could be something like 5x to the fourth, y to the third, z. Even though it has a bunch of different variables in it, it's still just one term. A binomial, we know that binomial, what we mean by that is that it means that we have 2. So it's going to mean that we have 2 terms. So it could be something like 5x to the fourth, y plus 4x to the third, and just something like that. And a trinomial, well, we know that tri means 3. So in this case, we could have 5x squared plus 4y plus maybe 8. So how do I add and subtract polynomials? What we're going to be doing is we are going to be combining the like terms. And if we remember that when you combine like terms, we're combining the like variables, but we are also combining the like exponent. So it has to be to the same exponent. Another thing that I need to point out is that here we'd be able to apply the associative property of addition because we have all addition and subtraction within this polynomial. So we're going to combine like terms here, and we'll have 3z squared plus 2z squared giving us 5z squared. And then remember, if we don't have a number before a variable, there is a number there. There's a 1 plus 3z, and then we'll combine, and I will have minus 7. So let's take a look at our next one. We have 8c squared minus 4c plus 1, and then we have plus negative 3c squared plus c plus 5. So we're going to combine right here, and we'll have 8c squared minus 3c squared. We'll have 5c squared. And then we're going to combine our negative 4c and we're going to plus 1c. So we'll have minus 3c and then plus 6. And now we've combined all the like terms. All right, so we're going to combine. We're going to have 2x squared combined with 1x squared. So we're going to have 3x squared. And now notice what's happening with the positive 5x and the minus 5x. Those are going to cancel out. You don't have to write 0 x's. We're just going to leave that off. And then now we're going to combine and we'll have plus 6. So in our next example, we're subtracting the polynomials. And we need to be careful when we're subtracting polynomials because this negative sign right here, it is going to be distributed amongst all the parts within our expression there. So we're going to take and we're going to distribute this negative, or you could even put a 1 there. And I'll rewrite the b squared minus 3b plus 2. And now we're going to have minus 4b squared minus 5b and then minus 1. So now we're ready to combine the like terms. And I'm going to take my 10b squared and combine that. Don't forget to circle the operation in front of it so you don't lose that subtraction sign. So we have 6b squared. Now let's take our negative 3b and our minus 5b. We have negative 8b. And then our last one then is going to be then just plus 1. And now we've simplified this one as far as we can. All right, so for our next example, we have a subtraction again. So again, we're going to distribute this minus to both parts. I'm going to distribute, and I'm going to have a negative 1m minus 2. And then we'll just rewrite the other problem up here. All right, so now let's combine our like terms. So I don't have anything to combine with this negative 4m squared, so I'm just going to leave that alone. And then we're going to look at our m's. So 3m minus 1m is going to give us positive 2m. And then let's combine our numbers without the variables, and that'll give us a negative 3. All right, so for our next example, again, we're going to distribute that negative. And now notice that, so I'll rewrite my 3m plus 4 minus 2m squared. Now a negative and a negative make a positive, so that's going to be plus 6m minus 5. So again, let's combine our like terms. And I'm going to start by writing them. I'm going to start by writing our m squareds first, so it goes in descending order. Negative 2m squared, and then we have 3m combined with 6m, which is 9m, and 4 minus 5 will give us a negative 1. And now we've got that one finished. All right, so for our next example, we're taking a look, and you have to find the variables that match. And so I'm going to start with my 3m squared n, and I'm going to combine that here then with negative 6m squared n. So I'll have negative 3m squared n, and then let's see, we've got this 7mn, and that can be combined with the 10mn plus 17mn. And now notice that we don't have any other like terms to the like powers. So I'll take the minus 10n to the third plus 9n squared. And then because this one is written in alphabetical order with the m squareds and then descending order going to the n's and so forth. But if you had written your n's before your m's, it's not that it's wrong. It's just that this is the standard way of writing them. All right, so for our next example, we're going to find the perimeter of this parallelogram. So we're going to combine our x's with our x's and our numbers then here with the numbers. So I'm going to take and we're going to add together all of our x's, because remember when you find the perimeter, you're adding up all the sides. So I'll have 10x and then plus then 2. That's been simplified as far as it can go. All right, now our last example, it says the floor of a home has a floor plan shown. Find the area of the floor. All right, so let's go ahead and we're going to take a look and we're going to multiply then together the sides, and then we have to combine any like terms. So to find the area of this area right here, we would take 4x times x, which then is going to give us 4x squared. All right, so now let's go ahead and let's find the area of this piece right here. So I'm going to take x all over 2 times x all over 2, and we'll have x squared on the top and 4 on the bottom. And then that's equal to, there's a 1 right here, so you'd have a 1 all over 4x squared. And now let's go ahead and we'll take a look at finding the area here, and we'll have 8 times x minus 4, and we'll have 8x minus 32. So now we need to go and take and add together or put together all of our like terms here into one answer. So notice I have the like terms, the x squareds. So I will have 4 1/4 x squared, and then we're going to have plus our 8x minus 32. So in this lesson, we took a look at adding and subtracting polynomials.